Welcome back to Wood Engineering. I'm Jeff Orochko from Carleton University, and in this video we're going to talk about the macro and microscopic structure of wood. So we're going to start by looking at the cross-section of a tree. Most people have seen something like this before. I'm going to assume. What might you know about a tree coming into this course? You probably are aware that trees have rings in the cross-section, so you can see the rings in this photograph. And you probably also know that each ring represents 1 year of growth for the tree. The other thing you might know is that the tree has bark, and the bark is the outer surface of the tree that covers and protects the interior. But if we dive down a bit deeper, what do we see? Okay, so we have here some different kinds of wood. We've got the cambium, which is the part of the tree that I guess does all the work of growth. And then we've got the bark. Okay, so the heartwood is a harder kind of wood that's typically in the interior part of a tree. If you look at the cross section like in the previous one, you can see actually a color difference between the heartwood of the tree and the sapwood of the tree. You might not always notice that if you look at a tree cross section. The sapwood is where you're going to have most of the movement of materials. So this is kind of the more alive part of the tree as far as moving nutrients and materials. And the cambium, as I mentioned, is the layer in between the interior heartwood and sapwood and the bark. And this is where the yearly growth happens. So the cambium grows inside to make the inside of the tree, and it grows outside to grow the outer bark. So the bark you can think of kind of like a sacrificial layer, which is kind of like our skin, where any kind of material damage to the tree can slough off parts of the bark, but it's still protecting the inside. So the cambium is where the growth happens, and that's why you get those rings, because every year the cambium induces growth. The pith is the very center part of the tree, and this is the part of the tree that's responsible for the vertical growth. So trees grow up, but they also grow outwards. And the pith is the part that grows up. And actually at the top of a tree, you're always going to have one kind of vertical branch, which is the branch that is the part that is basically the continuation of the trunk going upwards. And that's the pith. That basically represents the pith. So what happens when you have branches, and what are knots? I mean, the other thing that we all probably know about wood just from dealing with lumber or dealing with logs, if we're going camping or something like that, is that wood has knots. And those knots actually represent branches of the tree that are within the tree itself. So if we had a knot, if we had a branch that was growing and for some reason the branch went away, then we might have clear wood on the outside of the knot, which you can see right over here. And at the top, you can see a branch that goes all the way outside of the tree. Okay, so each year we have these annual growth rings, which I kind of alluded to earlier. And each year we get a different ring. Now, why do we have it as a form of a ring? Like, why can we see it at all? It's because the tree grows differently in different times of the year. So in the springtime, when there's lots of nutrients, we have a different kind of wood that's growing from the cambium interior of the cambium. And in the late season, when the tree's not growing as fast, the structure of the wood is a bit different. So that's why we can actually tell the difference in the color of the wood, and we can see a visible indication of the tree. So here you can see the early wood, which is the spring wood, is a lighter color, typically, and the late wood is a darker color. And that's because if we were to zoom in on that, and we're looking at one ring now, the early wood, you can see nice big cells, and the late wood, you can see that they're kind of more compressed, okay, because there wasn't as many nutrients to drive the growth during that time of year, the late season of the tree's growth. And the other thing that you can see in this slide is that the tree is made of long fibrils. And these long fibrils are all aligned longitudinally with the growth of the tree. So they all are pointing up and down if you're looking at the tree. Here, since we're looking at a cross section, they're pointing left and right. And these fibrils can have different lengths depending on what the tree species is. So here, for example, we have, if for softwoods, they tend to be a little bit longer, these fibers, and for hardwoods, they tend to be a bit shorter. But here you can see what the actual scale of these is. About 3 to 5 millimeters long in softwoods, which are the woods that we deal with typically in construction, and about 0.04 of a millimeter around. And you can think of these like they're all a bunch of kind of straws lined up, because they're all hollow tubes, all of these individual tree fibers. So if we were to look at kind of what it more looks like in reality compared to the previous slide, which is kind of a representation, you can see these long kind of tree cells. The late wood ones are a bit beefier and more compressed, and the early wood ones are larger holes. Obviously, the real structure of the tree is more complicated than what we saw in the previous slide. We have these rays, which are radial in the tree and transmit nutrients as well, but aren't typically very significant in the structural properties of the tree. If we were to look at an actual micro view of what these tree cells look like, you can see the walls are pretty thin. You can see in this picture the early the early spring wood portion, and also the late wood. So you can see the changes gradual as the growing season changes towards getting a more dense compaction of these cells. These larger ones are for moving resin in the tree, which is kind of a defense mechanism of the tree. Here's another picture of another softwood specimen with a different dye, so you can see way up close what these look like. So they're not perfectly round, but you can see that it's kind of a matrix. They all stack up together, and they're actually all joined together by a material called lignin, which we're going to talk about in a bit. And those two previous ones were softwoods. This is an example of a hardwood cross-section. So you can see that the fibers are considerably more dense. You can see the walls are thicker, and this increases the density, and it also increases the strength. But of course, we know hardwoods are quite a lot more expensive than softwoods, and softwood lumber is faster growing. So this is typically what we use for construction in North America anyways, and in Europe. If we look at the fibers vertically, so now we're looking at a radial section. So instead of looking at the chopped cross section of the tree and looking down, now we're looking from the side so that you can see the fibers vertically. You can see those rays, which transmit nutrients in the perpendicular direction to growth. And you can see the long tubes. Basically, this is a cut through those tubes. Very neat photographs. I got these on the web. You can check out that website if you want to see some more. These got a lot of nature close-ups, which are pretty neat. Okay, so let's look in more detail at what these walls look like. So we're back to the schematic. So obviously things are not quite as clean as shown here, but this gives a pretty good idea of what this looks like. So each of these cell walls, which you remember look very thin on the micrographs, themselves have a microstructure. So they have a primary cell wall on the outside, and then they have multiple secondary cell walls on the inside, which are the ones that provide the most strength. They have different directions, which we're going to talk about in a second. And then binding all of these cells together, we have a binder, which is a material called lignin. So even within the cells, the cellulose, which is the material that makes up the majority of the tree, which you've probably heard of cellulose before. It's like a natural polymer. Themselves are held together in a matrix. What a matrix is, we talk about this in structural engineering a lot too. A matrix is just basically a binder that holds together some other kind of material. So for example, if we're talking about carbon fiber, carbon fiber like you have in hockey sticks and stuff like that, the fibers themselves are held together in a matrix, and that matrix is basically the epoxy that holds them all together. So in this case, instead of carbon fibers, we have these microfibrils, which are chains of cellulose, and they're all held together by this lignin matrix. So the lignin is like the, serves the same purpose as the epoxy in a carbon fiber. So all of these have different, all these layers have different directions. The primary layer that provides a strength is this middle layer here, which is in the vertical direction. So this is what gives the wood strength in the vertical direction. And one thing that we'll learn when we talk about the strength of wood materials is that wood is strongest in the axial direction. That's the direction that lines up with the direction of the fibers. So which is the same direction as the tree grows, up and down. And then we have some off-diagonal horizontal fiber layers on the inside and outside. And one way to think about this structurally, if you've taken concrete already, is that the vertical is a bit like the vertical steel in a concrete column, for example. It's good in tension and compression, but not necessarily good in the out of plane direction, because you could imagine that if these are very long, they could buckle. And then you have these other layers on the inside and outside, which act kind of like the stirrups in a concrete column and contain the buckling and the movement of these interior vertical fibers. So they're providing kind of a confinement to this cell, which is very neat. And then we have the lignin binder, which holds everything together inside the cell and also between the cells. So you can see here where we get our strength. So we have our strength vertically from this interior, like the middle secondary fiber section. And then we also have some strength in the perpendicular direction caused by these outer layers, as well as providing the confinement effect. Okay, so these tubes do have some resistance to compression in this direction, but as we'll see when we talk about strength, not a ton, not compared to the vertical strength. So if we were to break this all up into components, how much of the wood is made of each material? Cellulose and hemicellulose, you can see, make up the vast majority. And then the lignin is the secondary material. So if we were just to divide all the materials and put them into bins. And then we have some ash and some other miscellaneous materials in the third set. So you can see mostly it's cellulose, hemicellulose, and then lignin. Okay, so if we want to build something out of wood, the species of the wood is going to make a big difference, because we're talking about an organic material, and organic materials' properties can change depending on not only which individual specimen we're talking about, which individual tree, but also which kind of tree. And different kinds of trees might be better for different kinds of things. So I alluded to this difference between hardwoods and softwoods. So you've probably heard of softwoods and hardwoods before. You've probably also heard of coniferous trees, which are also called evergreen trees, right? And broadleaf trees, which are deciduous trees. Like this all goes way back to, grade 2, grade 3. But you may not have made the connection that hardwoods are the deciduous trees and softwoods are the conifers. Softwoods are the pine trees and the spruce trees and all of the evergreen trees. So when we're talking about softwood lumber in Canada, we're primarily talking about chopping down pine, spruce, and fir kind of trees for construction. And trees like oak and maple and birch and elm, woods that we're all very familiar with in terms of furniture making, or in terms of, burning wood in the forest for a campfire, are not types of wood that we typically use for construction. So these, again, are the woods that we'll use for construction: spruce, pine, fir, cedar trees, hemlocks, and larches, which do themselves have many different kinds of species across Canada. So, spruce is not just a spruce. There's a black spruce. I don't remember what other kind of spruce we're going to see on a future slide. There's different kind of pine trees. Obviously, there's red pine, white pine. So even within the individual species or the individual species group, there are individual species themselves which can have different properties. So this is a table from the Introduction to Wood Design book, which shows all of the different kind of woods that are used in Canada. And Also, there are different characteristics, so it might be a bit difficult for you to read the details, but some of the details that are here are, like how resistant is that wood to decay. You may know, for example, that cedar is very decay resistant, so that's often a wood that we'll use to build decks. Materials that have to be stored outside. Some are higher in strength, some are lower in strength, some can hold nails really well. But if we zoom in a little bit, you can see the kinds of trees actually that we're talking about in terms of, if we're going to buy something at our hardware store, what are we going to get? And in the wood design standard 086, these tree species are all divided up into different categories. So instead of needing to know what exact species that we're going to use, all we need to know is what category that species fits into. And then depending on the category, we have some design strengths that we can use. And those design strengths are supposed to cover, all the species under that category. So for example, in the Eastern Canada, where we are, a very common construction species is all divided into this category SPF, which if you go to, you go to the hardware store and you buy some lumber, you'll see SPF stamped on there commonly, and that represents spruce, pine, fir, which means it's a combination of all sorts of different species that could be represented in that category. So if I get a piece of lumber from Home Depot or something, then it could be jack pine, could be spruce, could be balsam fir. It depends on where exactly you are and what the lumberyard is that they source the materials from. And likewise in the West, common species are more, Douglas fir. Douglas fir larch, for example, is something that you typically find in the West, but not so much in the East. So that does it for structure, macrostructure, and microstructure of wood. Thanks for following along, and we'll see you next time.